minutes and 4.1 seconds. I'm sorry, that number is not the number of days. That is the number of sidereal rotations. Number of days will be slightly less than that. Okay, because there is a difference between civil day and sidereal day. Civil day is in average time taken from sunrise to sunrise, whereas sidereal day is the time taken between two starrise and starry. One particular star, one day, and the next day very distinct. So that will be slightly less than 24 hours. So it's about 23 hours, 56 minutes, 4.1 seconds. So that is what is implied from Aryabhata, and the modern value is 23 hours, 56 minutes, 4.091 seconds. So it's such an accurate figure he is giving. Again, he mentioned that the Earth rotates through 1 minute of arc in one prana, that is 4 sidereal seconds. Among other things, we highlight two very important features described in Aryabhata. This also has been mentioned, just tell you briefly. So the value of pi is described in the following, but that also was mentioned. Chaturadikam Shatamattabunam Dva Shashti Tatha Sahasranam Ayutadvaya Vishkambhasya Asarnaha Vrutta Parinaha Aha. So the circumference of the circle of diameter 20,000 is nearly 62,832. So this will correspond to a value of pi equal to so circumference by diameter, so 3.1416, which is correct to 4 decimal places. So it's very significant that he says Asannaha, that is close to that. It is not the exact resistance. So because the reason, now we know that it is a irrational number. It cannot be expressed as a ratio of two numbers. So this is later some of the astronomer mathematicians, they tell about this aspect of irrationality. So Neelakanta Somyaji's name has already been mentioned. He says that suppose you give some number, integers for diameter of a circle, however large, the circumference will not be integer. Similarly, if you give the circumference as an integer, the diameter cannot be integer. So what he is meaning is that circumference by diameter cannot be expressed as a ratio of two rational numbers. So that means it is irrational. Of course, Aryabhata doesn't go into all that. He has mentioned it is an approximate figure and he has given this number. Similarly, rotation of the Earth also was rotation of the Earth also was mentioned. So just as a man, both moving forward sees the stationary objects as moving backward, just so are the stationary stars seen by people at Lanka on the equator as moving exactly towards the east. So he is talking of relative motion. So just like a person in a boat moving forward, he sees that the bank and all these trees and people, they are all moving backward. But that is not true. What is happening is you are moving with the boat. So similarly, though we see that the stars, planets, etc., they are all moving from west to east. Whereas what is happening actually is east to west. What is happening is that the Earth rotates from west to east. So that is what is implied by this. So now, let us come to some aspects of Aryabhata and take it up in a little bit of detail. So he talks of what is known as the Puttaka or pulverizer algorithm. So the subject of this first order indeterminate equations was considered very important by ancient Indian mathematicians, and most of them had dealt with Puttaka or pulverizer method. And the first text to go through that is indeed they give it in detail in Aryabhata. So they are important in astronomy also. They come in various astronomy problems. For instance, in the calculation of Aryabhata, the number of days elapsed from a given epoch, from the mean longitude, how you calculate it. So this algorithm also plays a crucial role in the second solution of much more difficult second order indeterminate equations. We will not go to that. So what is this? Okay? What is the problem? In one of its versions, the problem is to find think I will do without the mic. I am quite, like I talk quite loudly. So, not better, even better. Yeah. So the problem is this. So find an integer n which being divided by two given integers a, b will leave two given remainders r1, r2. So that is, if I have to find an integer n such that when it is divided by a, it gives a remainder r1, and divided by b, it gives a remainder r2. So n is equal to ax plus r1 is equal to by plus r2. Or another way of putting this class of problems is, see, suppose you want to solve this equation, ax plus c is equal to by. Okay? So a, c, b, they are all constant given integers. Given integers. Okay? So given integers. So you have to find a solution for this. Is it visible? Okay, I will make it maybe bigger. Okay, you have to find a solution for this. See, you may say that suppose you give any number x, you can always find y by this. But the problem is the values of x and y must be integers. Okay? Suppose you find some integer value of x. If you give an integer x, but ax plus c must be equal to b into y. That means ax plus c must be divisible by b. Right? So any integer x will not do. So it has to match such that x and y are both integers and they satisfy this equation. So this is called the Kuttaka. It's called linear indeterminate equation. Okay? Indeterminate means that there may be several solutions of that. Okay? It doesn't determine the thing fully. Solution fully.
More variables.
More variables. Yes. More variables than the number of solvables. Okay? Or less variable than the number of
no, two variables and one equation.
Two variables and only one equation is there, and two variables are there. So naturally it is not a unique thing. Of course, you could have quadratic indeterminate equation, so like dx square plus 1 is equal to y square. So this is, given some integer d, you have to find x and y such that both are integers such that this equation is satisfied. This is much more difficult. The special methods have to be devised to solve this. This is called Varga Prakriti. Okay? So we will not consider that, we just use the simple thing. So we will consider one of the linear indeterminate equation of this nature. In fact, most of the most of the texts in mathematics astronomy in India, they dealt with this kind of problem, Kuttaka problems. In fact, algebra was called as Kuttaka. So in Aryabhata, he has given the a method to solve this equation in two verses. Adhikagra bhagaharam Chindya Unagra Bhagaharena Shesha Paraspara Bhaktam Madhiguna Maglantare Shiptam Ada Upari Gunitam Antya Yugun Unagra Cheda Bhajite Sheshan Adhikagra Cheda Gunam Vichedagram Adhikagra Yuta. So, of course, I am sure nobody will understand if I just recite like this. So, the translation also is given. So I will not go into this deep, because again translation also. So I will just describe it. Okay. So what do you have to do? You have to solve this problem. Okay. You have to solve ax plus c is equal to by, right? So that is what you have to solve. Where a is given, b is given, c is given. Okay? So now what you do is you mutually divide A and B. In fact, that is the procedure to find out the greatest common divisor, right? The Euclidean algorithm, as it is called. So you mutually divide. So that's the paraspara, this thing, bhagahara. So A, so suppose A is greater than B, so you divide A by B, okay? So the quotient is Q and the remainder is R1, okay? So now divide B by R1, okay? So like that you continue till you get these quotients, Q, Q1, Q2, etc., Q2n, and the last remainder is R2n plus 1, okay? So that is the thing. So these are the quotients, and the last remainder is R2n plus 1. Okay, now according to the method given in Aryabhata, a number T, Mati, is called Mati, is chosen such that the last remainder you get, okay, R21 plus 1, that when multiplied by T plus adding C, that must be divisible by R21 with quotient S, okay. So that is how you have to choose your T. Then in that case, after you do that, to write it in terms of a column called Valli, okay. So you forget about the first quotient Q, okay. So you have got a set of quotients Q1 to Q2n. That right now I'm assuming that the number of quotients except Q is even Q2n. So then you are choosing T such that I told you or 2n plus 1 into T plus C is